My name is Tom Endyke, and I'm a Director of Solutions Architecture for Ontotext, and I'll be your MC today. And in terms of logistics, we're going to be recording this webinar, and we'll be taking questions from the Q&A panel as we move along. So that's on the bottom, should be on the bottom right of your WebEx screen. When you do submit questions, I remind you and ask, please select all panelists so that no questions get unnoticed or unanswered. So I'd like to share a few thoughts before I turn the webinar over to our presenter, Marin Dimitrov. And that is, if you're here today, chances are you're researching solutions and technologies around database as a service offerings. Ontotext offering in this space is our flagship GraphDB database, hosted on the S4 or the self-service semantic suite platform. This model is extremely powerful and powers smart data applications across many vertical markets, including media and publishing, healthcare, life sciences, as well as digital libraries. So today, Marin Dimitrov, Ontotext CTO, will be discussing the value of RDF graph databases, the architecture of our database as a service, provide you some examples and use cases, and also discuss and show our product roadmap. So we're excited to present this information to you today, and without further ado, I'll hand it over to Marin Dimitrov. It's all yours, Marin.
Thank you, Tom. Good afternoon or good morning, everyone, and thank you again for joining this webinar. So what are the topics that we will briefly cover in the next hour or so? A brief summary of the self-service semantic suite that Tom already introduced. Then I want to talk a little bit about RDF graph databases, what are the advantages, typical use cases and applications. And then we will move on to the core of today's webinar, basically the RDF graph database available as a service provided by Ontotext. I will have a very short demo just to show everybody how they can easily use the database as a service, and some closing remarks regarding our work in progress and immediate product roadmap, and we will conclude with a questions and answers session, based, of course, on your questions. Okay, so about Ontotext, we provide products and solutions for content enrichment, information discovery, and metadata management. The team is around 70 employees. Headquarters are in Bulgaria, but we also have sales presence in the United States and in the UK. As Tom already mentioned, the major customers and verticals are for our solutions are media and publishing, life sciences and healthcare, digital libraries, cultural heritage organizations, government or educational organizations as well. And a short list of some of our current customers. As you can see, we help organizations of various sizes and of various industry sectors, media, healthcare, pharmaceuticals, government organizations. Okay, so moving on, what is Ontotext vision for smart data management? So let's start from the beginning. We, of course, use RDF and graph databases and graph data models so that we can quickly and easily integrate heterogeneous data sources. We use ontologies to model and map between various schema and vocabularies. We apply a lot of text mining and analytics so that we can identify from free-flowing text mentions of people, locations, events, organizations, topics, and so that we can interlink them into a knowledge graph. We, of course, also in many cases, we reuse available open knowledge graphs all into open data. And the end result is that on top of this knowledge graph that integrates both structured, semi-structured, and unstructured data sources, we can provide more powerful semantic exploratory search or generate metadata-driven websites and content. Just a quick summary of some interesting success stories of Ontotext solutions and products. So with AstraZeneca, the goal was to deliver a platform that helps researchers performing clinical studies to basically be more efficient, to have access to all the data available, to improve the decision-making process. The challenge was that a lot of the data was spread across really large number of textual documents or different document repositories, data silos, and typical traditional keyword-based search returns thousands of documents, which is very inefficient for the clinical researcher. And the solution that we provided for AstraZeneca basically analyzed the textual content and the structure, of course, of these thousands of documents. Interesting pieces of knowledge and information are extracted, integrated together into the graph database, into GraphDB. And the end result is that we can perform more powerful semantic search, delivering precise answers to researchers rather than just links to hundreds or thousands of documents. Another interesting success story is with Financial Times. The goal was to create a platform for content enrichment and personalized recommendation of content based on semantic technologies. And of course, the challenges were that we had to deliver production-ready systems in a very short period, and this is a critical part of the whole publishing workflow for the Financial Times. And again, in our solutions, we analyzed all the textual information, extracted interesting pieces of information, organizations, people, the relations between them, and everything is interlinked so that basically relevant content can be identified quickly and recommended. And a final showcase with LMI, where the goal was to basically provide, again, more efficient search over really large collections of complex documents and to improve the productivity of analysts. The challenge was that, again, traditional keyword search returns really hundreds of documents, really large documents. It takes hours to the analyst to filter and find the relevant information. So we had to analyze, again, apply text mining technology, analyze the content of these documents, extract all the interesting information, interlinked it into a graph, into a knowledge graph powered by GraphDB, our graph database, which, according to LMI, basically resulted in 90% savings in time, analyst time, searching and finding relevant content. And actually, this showcase won the Innovation Award of the Washington Post a year ago. Moving on. The self-service semantic suite that Tom already briefly introduced. What is it? Why did we create it? So S4 provides capabilities for text analytics, content enrichment, and smart data management, everything running on the cloud, available on demand as a service. So basically services for analytics, text analytics of news, biomedical, life science documents, social media, tweet. RDF graph databases as a service running in the cloud, which is the focus of today's webinar. And the third key component is access to large open knowledge graphs, providing interesting background information in various domains. As I said, everything is available on demand, anytime, anywhere. We provide simple, RESTful services to developers, and there is no need for upfront commitments. Everything is available with pay-per-use pricing. Again, a summary of what I already described, the three key components of the S4 platform: knowledge graphs, text analytics, and RDF data management. So we reuse a lot of knowledge graphs, interesting information coming from DBpedia, from Wikidata, Freebase, GeoNames, basically large knowledge bases providing interesting background information. We reuse this information to improve the quality of the text analytics process. The result of the text analytics process is basically we identify interesting mentions of people, locations, organizations, or in some specific verticals a really large number of biomedical entities. The resulting information, these facts, the entities and the links between them, they can be easily represented as RDF graph structures and graph structures stored and managed by an RDF graph database. Basically these the generated RDF graph data can additionally enrich existing knowledge graphs or generate new knowledge graphs. What are the benefits for developers in particular of using the self-service semantic suite? It enables quicker prototyping. As I said, it's instantly available. There is no need for delays by provisioning, no need to worry about operations. Basically, focus on building your smart data applications. Don't worry about the infrastructure. We provide a large free tier for all the three key services: text analytics, knowledge graphs, and RDF databases in the cloud. We've put a lot of effort to make the platform easy to use for use by developers. We have various add-ons to third-party tools, SDKs in various languages, Docker, demo code, and of course, basically the S4 platform is based on enterprise semantic technology by Ontotext, which I already mentioned, was applied successfully for large showcases, success stories in different verticals. Sorry. For developers, I already mentioned that we provide a large free tier for the services, so everybody can quickly register an account, generate API keys, and basically start accessing the various RESTful services for text analytics or the RDF databases running in the cloud. Okay, so this is not the topic of today's webinar, but I will spend a couple of minutes just talking about the text analytics and the knowledge graphs part of the S4 platform, and then I will move on to the focus of today's webinar. As I mentioned, we provide text analytics services running in the cloud for news annotation, news categorization, biomedical analytics, social media, Twitter analytics. Basically, we extract various entities, interesting entities in text, people, locations, organizations, or specific biomedical entities in this case. Everything is interlinked, disambiguated, and interlinked back to mapped to knowledge graphs such as DBP or geonames or specific biomedical data sources in the case of biomedical text analytics. The services basically can process various types of input documents, and the output is a very simple JSON structure that developers can further utilize in their applications. And this is actual example of analyzing a textual article with the S4 services and the JSON structures. So in particular, I'm not sure if the quality of the image is good enough, but here you can see that United States, the mention in the text is mapped to the proper entity from the geonames database, which is a large knowledge base for geospatial information. And the same for California, and we have two mentions of Barack Obama, which are mapped to the proper object from the entity from the DBPD knowledge base. Knowledge graphs, the second key component of the S4 platform. Basically, we provide access to the FactForge semantic data warehouse, integrating various open knowledge graphs, information about more than 500 million entities, and basically resulting in 5 billion triples is easily accessible via S4, and this information comes from key linked open data, knowledge graphs, DBPDF Rebase, now Wikidata, geonames. And it's for particular use cases, we of course deploy custom knowledge graphs. Some biomedical knowledge graphs are also available via the S4 platforms for particular cases. This is an example of how a developer can easily query the knowledge graph available via S4. In this case, we basically use background information from DBPD and geonames about airports and their specific locations. Okay, moving on to the RDF graph data management, the topic of today's webinar. So, what is the benefit of using RDF databases, RDF graph databases for data management? They provide means for schemaless agile data integration, so it's easy to integrate and query data coming from diverse heterogeneous data sources. This is actually usually a defining feature of most NoSQL databases, but there are some also differences between RDF graph databases and a lot of the existing NoSQL solutions. For example, RDF databases are based on standards. There is a lot of standard compliance and basically portability and interoperability between the different products and the different vendors. So there is no really a risk of vendor lock-in. Sorry. The SPARQL query language, query language for RDF data allows for very complex exploratory queries, even when the schema is not known well in advance. This is not usually the case with alternative NoSQL solutions. Implicit information in the graph can also be derived based on sound logical inference rules. This is a defining feature of RDF as a graph data model and RDF databases. I already mentioned a couple of times, there is a vast amount of knowledge of information currently openly available as open knowledge graphs or linked open data in the native RDF format, so it's easy to reuse and incorporate this external data with your proprietary custom data. And a more visual representation of RDF data, of course, is a graph model, graph data, so it's easy to interlink together pieces of data coming from different data sources. The RDF data model actually allows for really complex, you can create more precise, more complex schemas and data models, or ontologies as they're called for RDF and the semantic web, with hierarchies of classes, subclasses, properties, subproperties, complex transitive relations. This is really useful in a lot of domains where information is modeled in a complex way. Implicit relations can be derived automatically by the database, so even if some facts, basically in this case, that this particular coffee shop is located in Seattle, the database, based on the schema and the inference rules, the logical inference rules can derive more information. Well, it's also in Washington, also in the USA, so basically you can get richer results of queries based even on implicitly inferred facts. So in particular, the GraphDB database by Ontotext, our RDF graph database, it's a high-performance RDF database handling, managing tens of billions of triples in production environments. It provides full SPARQL 1.1 support. I mentioned already SPARQL is the query language for RDF data. 1.1 is the most recent version of the standard. The database supports various reasoning profiles, these logical inference rules that derive new implicit information based on the existing information. There are lots of specific optimizations in the graph database that make data integration more efficient, easier. So you can easily map between different schemata, different vocabularies, different data sources. You can efficiently delete statements. So all these features are quite important in some domains or some industry verticals or for some particular customers. On top of the standard SPARQL language, we provide specific, very useful extensions for geospatial indexing and querying. RDF rank, basically analyzing analytics on top of the RDF graph. Full text search, third-party plugins can be developed and deployed on top of the database. Recently we have introduced connectors to other data management systems, full-text search systems such as Rover or Elasticsearch. We have plans on the product roadmap, of course, such connectors to NoSQL databases. And last but not least, GraphDB Workbench environment, which is a user interface for managing databases or for working with RDF data. So that's a very quick summary of our key products, GraphDB. And in a recent report, analysis of the graph database vendor landscape by Bloor Research, Neo4j and Ontotext were identified as the champions, the leading champions on the vendor landscape with presence and products which are mature and available for many years, and that cannot be easily matched by most of the alternative solutions. Okay, moving on to the core of today's webinar, the RDF database as a service running on the cloud based on our GraphDB database. What is the purpose of the RDF Graph database as a service? Why did we build it? Why do we deliver it? It's an ideal solution for customers who are still evaluating or experimenting with RDF technology, RDF database technology, or they're in the early phases of adoption of the technology, perhaps building some proof of concept and pilot solutions. And basically, these customers still get an enterprise-grade RDF database available as a service without any need for upon payments, licenses, hardware provisioning. Basically, customers can pay only for what they use when they use it. Databases can be instantly operational within minutes, and of course, we want to make it simple for developers to work with RDF databases. There is no need for complex planning. They can start or stop as many database instances for as long as they're needed, and we take care of the upgrades of the software and all the operational details. Basically, the database as a service offerings of Ontotext based on the GraphDB database, they come in two flavors, a self-managed flavor and a fully managed flavor. And more details about each of the options. The self-managed RDF database, it's available. It has been actually available for a few months already via the Amazon Marketplace, Amazon Web Services Marketplace. So for those of you who are not familiar with the Amazon Marketplace, basically it provides a one-click environment for really quickly purchasing and deploying AMIs or software running on the Amazon cloud in a very easy and straightforward way where customers basically pay by the hour. So our particular database, GraphDB, running on the Amazon cloud, the customers have the choice on the particular hardware configuration they want to actually instantiate or deploy the software, the database, from 2 to 8 CPU cores and from 8 to 61 gigabytes of RAM. So based, of course, on the amount of data that the customers plans to manage, the customers have the freedom basically to choose the most optimal hardware configuration for managing this data. So, as I said, this is the same GraphDB database that we provide to our customers for the various on-premise solutions. So you get basically the same quality of software and the same performance. The database is suitable for managing large volumes of RDF graph data. And as I said, basically via the Amazon Marketplace, everything is available on pay-per-hour pricing. Basically, customers pay only for as long as they use the database. If they don't use it anymore, and they don't use it in particular period, they don't pay anything. Yeah, actually, I mentioned already the GraphDB, the self-managed version of GraphDB as a service is available via the Amazon Marketplace, so really easy to deploy, and the customer has the choice of the particular hardware environment on the cloud that the software will be provisioned on. The other flavor of our database as a service, the fully managed database as a service. Basically, it provides low-cost graph database running 24/7. It's very well suited for small to moderate data or query volumes, and we provide a set of predefined options, different database as a service options, based on the volume of data that the customer plans to manage, from 1 million triples, 10 million, so on, up to 1 billion triples of data. Again, similar to the self-managed database, these databases are instantly available and can be deployed whenever needed. And in this case, this is a difference, of course. This is a fully managed database, so we take care of all the administration details, all the operations, maintenance, upgrades. And again, users pay only for the actual database utilization, basically based on the amount of data and the query volume that they generate per month. And this is, of course, a feature of our GraphDB database. It supports the most popular APIs for RDF data management, OpenRDF or Sesame APIs. Yeah, basically, I mentioned this already. We provide several predefined flavors, options for the fully managed database, from really small amounts suitable for different amounts of data, from really small amounts, 1 million triples, up to quite moderate or even large amounts of 1 billion triples of data. And of course, the micro databases for up to 1 million triples, they're free. So you can register and start using them right away. Everything, of course, is a fully managed database running in the cloud database as a service. Everything available via simple web interfaces. You can create a new database, change various operational parameters, create repositories, and so on. And what are the typical use cases for RDF databases as a service? Actually, for most kinds of databases as a service. I mentioned already, a lot of companies are evaluating new technologies. Basically, semantic technologies are still relatively new technologies, even though they have huge potential in many verticals and many specific use cases. A lot of companies still don't have much experience with them, so we want to make it easy for these companies to quickly evaluate the technology and the benefits, the potential benefits. In many cases, actually, it's important to experiment faster. Basically, this instant availability and deployment of the databases is really useful. Avoid complex provisioning processes, procurement processes. We want to make application development faster and more efficient for developers. Focus on building your smart data applications, and don't worry about, installing, configuring, maintaining the RDF databases. Publishing open data or data services is also an interesting use case for such database as a service offerings. And last but not least, a lot of organizations basically are already seeing reduced costs and risks by using such RDF, such databases as a service, or RDF databases as a service for development purposes, for testing purposes, and in some cases even in production environments. A bit more technical, the next few slides are a bit more technical, targeting developers. So the fully managed RDF database in the cloud, I mentioned already, we use the Amazon cloud environment. We have developed, designed, and implemented a fully cloud-native architecture for the database as a service. It has been designed for high availability and elasticity, so basically more resources are added, like storage or computing power can be added whenever the database size grows. Of course, we have taken care to improve the availability and resilience of the platform, and since failures happen, of course, at some point, we make sure that failed nodes are instantly replaced, so that the operations of the database are not interrupted, or at least they're interrupted only for a really short period of a few seconds. I mentioned already GraphDB, the Ontotext RDF database, is the database engine powering our database as a service, and the OpenRDF REST API, the most popular API and platform for managing RDF data. We basically expose these APIs to developers on the cloud, so this is how they interact with the data. We have taken care to, of course, since this is a multi-tenant environment, we have taken good care of isolating properly the data and the software services running, managing the data of the different customers. We use Docker containerization technology for additional isolation. Basically, each database has its own network-attached storage or elastic box storage in Amazon Cloud terminology for storing the RDF data. And a couple of words on the OpenRDF REST API, the most popular API for interacting with RDF data. This is the API that our database as a service exposes to developers and to third-party applications and tools. Brief summary, of course, developers or applications can get the list of repositories on the database. For each particular repository, they can create, of course, repositories, delete repositories, query repositories. On the statement level, the statements of each repositories, developers and applications can add, update, read, delete concrete statements, basically RDF data. Of course, they can, if they decide so, they can work with concrete name graphs within the repository. And we have implemented some additional extensions on top of the OpenRDF REST API that are for customers using our database as a service. They can provide via the RESTful interface. They can also provide some simple configuration options for how the database as a service works. We'll show this actually during the demo session. This is a third-party tool, the OpenRDF Workbench. It's an open-source free tool. So, of course, since our database as a service is compliant with the OpenRDF API, RESTful API, all the tools, there are lots of tools that work directly with this RESTful API. So, basically, you can use whatever tools of choice. You have third-party tools. Basically, you can add data. You can see here, basically, we're working with an actual database running on the S4 platform. Our database running in the cloud. You can, of course, developers can add data in many other ways. Simple, using the RESTful API with simple scripts like curl. In this case, as I mentioned already, the statements resource of the RESTful API, the post and put operations, add or update data. In this case, we upload a simple file with RDF data into the database via the RESTful API. And of course, developers can use Java or other languages. The OpenRDF SDK is available for various development languages. So since we are fully compatible with the OpenRDF RESTful API, all these SDKs can directly be used by developers to work with our database as a service running in the cloud as if it's working on-premise, basically standard RDF database. Querying data, again, we can use a variety of third-party, open source, or commercial RDF tools. Basically send Sparkle queries to the endpoint, to the database running in the cloud, get some results. We can do the same with a programming language like Java or with simple scripts like curl. In this case, I mentioned that for the repository resource, get and post operations actually query the database, the particular repository in the database. Yeah, actually we are pretty well on schedule and moving on to the demo slot. So I will provide a simple, a full detailed actually step-by-step run-through of the demo of the different steps before actually performing the steps, so that you can understand better what we will be doing, and just in case, of course, if something breaks down in the last second and doesn't work, we at least have the demo scenario explained in detail. Let's see. So what is the demo scenario? Create a database, create a repository in this database, upload some simple sample data in this repository, query the data, basically uploading the data, querying the data, and exploring the data is done with different third-party tools. Basically, as I said, we provide the database is running in the cloud expose a standard RESTful API, the OpenRDF API, so various third-party tools can actually be used to manage the data in the database stored on the database as a service, or to visualize it and explore it. And yeah, I'm basically showing the different steps we'll perform during the demo. So creating a database, I mentioned we support different kinds of database sizes. Currently, actually, only the free micro databases are available. We'll be soon deploying the other versions as well. So I mentioned already data as a service and open data services. In a lot of scenarios, actually, it's useful to provide read-only access, public read-only access to the data stored in some repository, so that basically users or developers or applications don't really need a private API key to access your database. This is read-only access. And as I mentioned, basically all the RESTful APIs running on the S4 platform, they require a valid API key pair so that they can be accessed and access can be authorized and authenticated. Once we have created the new database and created, we have to create basically a repository. So what is important here is to choose the specific inference rule set. So when I talked about RDF inference and RDF graph databases, I mentioned this automated inference of new facts based on the logical rules. The RDF, the GraphDB database by default supports various inference rule sets, from very simple ones like RDF to quite complex ones like the RL subset of the auto language. So, of course, yeah, in this example, we will choose a really simple inference rule set because we really have really simple data to work with. Then we use a third-party tool, the OpenRDF Workbench, to connect to our database. This is the endpoint to the database running in the cloud. We will upload some sample data. The sample data is like 120 triples. It's a subset data coming from DBpedia, from the DBpedia knowledge graph. Basically, some information about countries in Europe, capitals, population sizes of the capitals and the countries. As you can see, it's incomplete. It's not a full extract. It's a minimal extract of data. So actually, lots of countries and a lot of capitals are missing, but this is actually more than enough for our demo. Next step is, we basically will upload the sample data with the third-party open source tool, the OpenRDF Workbench, which just accesses the standard RESTful API. It's being authenticated properly in this case with the private API key pair. Basically, for all modifications of data and accessing the database, you need such authentication and authorization. And we upload the sample data. I said it's like 120 triples for European countries and capitals. We run a sample query with this third-party tool again, OpenRDF Workbench, see the results. Then we use another tool, Metreeca Rover, which is an interesting tool for visualizing and exploring RDF data. In this case, we just have to provide to these two, the Sparkle endpoints. The rest is full service, basically, that serves queries, Sparkle queries, so that the tool can explore and visualize the data. And we will basically show how to navigate the sample data we have just uploaded into the database, filter the data, provide simple facade search, and some simple chart-based visualization of the RDF data that we have just uploaded into the database as a service running into the cloud. Okay, so let's move on to the live demo.
And Marin, I just wanted to remind the attendees that if you have questions during the demo or if anything is burning that you'd like answered, please submit your question to the QA panel within WebEx, and we'll get to it. We'll save some time at the end of the demo to address those. Thank you.
Thank you, Dom. Okay, so moving on to the demo. We sign into the S4 platform where the database as a service is running. If you don't have your developer account, you can quickly create one and use the services for free. As I said, basically all the access to the various services running in the cloud on the S4 platform, you need private API key pairs. So you need to generate some if you don't have a valid API key pair. We have one in this case. We're going to use it. So switching to the database management tab, we can create a new database. As I said, only the really small ones, the micro databases for up to 1 million triples are currently available. We will be gradually deploying the other bigger options as well. As I said, you can enable public read-only access to the data if you plan to host open data services or open knowledge graphs. So let's not actually create a new database. Let's reuse this existing one that we have. And as you can see, there are no repositories. Basically, there is no way for us to store data currently. We have to create a repository first. But let's first connect actually to the database is running already. I said we are not creating a new one. We just reuse an existing one for demo purposes. Let's create this database via the OpenRDF Workbench. OpenRDF Workbench, I said, it's a free open source tools for managing RDF databases and querying, exploring RDF data. It's a web-based tool. In this case, it's running locally on my machine. And let's connect to the database. I just copy and paste the URL of the database, and I have to select a valid API key pair. In this case, this is the one I'm going to use. So here it is. Basically, with this third-party user interface tool for managing databases and data, we have already connected to the database as a service running into the cloud. And there are no repositories apart from the system one. This is a special repository, of course, so please don't modify data in it. It has very special purpose for the database. And we are not connected actually to any particular repository. As I said, we don't have one currently. So let's create a simple repository. Let's ignore all the other details. The most important thing is really choosing the particular inference rule set, basically how the database will operate and infer new logical facts based on the facts that you already have in the database. Let's use a really simple database, RDFS, because our data is really simple. Actually, we don't really need anything more complex. The database automatically assigns all the memory available for cache to this repository because there are no other repositories, of course. And okay, now we have an actual running repository, and this is the endpoint for this repository. Let's copy this URL. No, actually, we don't need to copy it yet. I just need to refresh. I mentioned already the OpenRDF Workbench is already connected to the database, and now we already see the repository that we have just connected, created on the database as a service running on S4. We have now connected to this repository in the database. So next thing we can do is, of course, yeah, you can see here already there are 0 statements. So we can't really do anything. We can't query any data before we actually add data. So let's add data with this tool. Let's, of course, again, ignore all the details. Basically, let's just upload this sample file with 120 or so RDF triples. I can actually show you the file. So as you can see, really simple information. Extract from DBpedia about European countries, capitals, population. So yeah, we upload this sample file. And now we already have 420 triples in the database. Again, a reminder, the database is running in the cloud as a service. This web-based tool is running on my machine. You can, of course, host it somewhere else, and it's connecting remotely to the database as a service via the standard OpenRDF REST API. So we have the data already. Let's do a simple query. In this case, my browser has cached actually a query I already run. So basically, it's a Sparkle query. For those who are familiar with Sparkle, basically give me information about the countries and the population from the sample data that we uploaded. But I also want to get only the top 5, basically sort the results based on the population of the country and give me only the top 5 results. So let's execute it, again, by accessing the RESTful API for the database as a service running in the cloud, and to get some results here. And again, as a reminder, the data set that we have is incomplete, so obviously some countries like France are missing. Actually, a lot of countries are missing from this data set. But this is enough for our purposes. Okay, so a reminder, we have uploaded the sample data with the third-party tool, open source tool, and we have queried already. We have already performed our first query. Next step, let's actually explore the data in a bit, in a more interesting way. For this, we use another third-party tool, the Metreeca Graph Rover. So basically, this tool just needs the Sparkle endpoint, basically the RESTful service that can answer Sparkle queries. This is everything, all that the tool needs so that it can already start visualizing and exploring our data. Let's actually, that was the URL that we needed, the Sparkle endpoint for the repository. Basically, we have the data in our single repository, and this is the Sparkle endpoint that third-party tools can use to query the data. Let's just copy the URL, and we are connected already. So basically the tool realized that we have like 2 classes available in this sample data set of 100 triples, information about countries and places, which are the locations. So let's try to explore the data a bit more. Let's add information about the population of the country. In this case, the DBpedia property relation, it's called population census. Let's rename it because it's not very descriptive. Let's add more information. I mentioned already that, and showed also that we have information about some of the capitals for these countries. And in some cases, we also have the information about the population of the capital. In this case, the property of the relation is called population total. This is the population of the populated place or the city. Let's again rename it so that we don't confuse it with the other population. And yeah, basically you can see here these 120 triples providing information about various countries, their populations, maybe in some cases the capitals and the population of the capitals. It's incomplete, but anyways, good enough for our purposes. Let's do some faceted search. Try to basically filter the information in some way. Let's say that we want information about countries with at least 10 million people. So that's the list. We can also filter additionally based on the other property, the population of the capital. Let's say we want capitals bigger than 2.5 million people. So we have some, basically, yeah, you get the idea. You can explore the information any way you want. And again, a reminder, the information is stored on our database service running into the cloud, on the cloud. And this is a third-party tool, web-based tool that I'm accessing. Let's create some better visualizations. So we can create a pie chart based on this sample data. With the countries, European countries with population more than 10 million people. We can do actually the opposite. Let's see which are the smaller countries. So lots of them. We can, yeah, basically the tool provides means for visualizing this information in various ways, charts. Or of course we can switch back to the original tabular view of the data, and this data can be exported to CSV or the subset of the data. So this is actually the end of the really short demo, and we are still mostly on time. A summary, what we did was actually we didn't create a database, we just used an existing database to save a few seconds. We created a repository, we uploaded sample data into the repository via a third-party tool, and then we explored and queried this data via 2 different third-party tools. The database is running in the cloud, data is in the cloud, and these different tools are web-based, locally accessible. So let's conclude with the roadmap, what's on our work agenda, what's already in progress. We are still adding various improvements to the database as a service, in particular the backups and the automated backups and exports are still not fully functional, so we are working to make this functionality available as soon as possible. We will be gradually introducing the bigger database options. Right now only the database for up to 1 million triple is freely available to developers. We will introduce bigger database as a service options, including for large data volumes up to 1 billion triples. We plan to put additional efforts into improving the availability of our cloud platform. cross-data center application for improved availability of the data and database services. Integration with the GraphDB Workbench. I already showed you the OpenRDF Workbench, which is an open source tool for managing the RDF database and managing the data. So for customers of the GraphDB, our database, they also have access to the GraphDB Workbench. It's a tool they can use for free with our database. And again, it's useful for managing the database or for querying the database. Gives a very useful user interface for querying and exploring RDF data. So it's on our agenda to, of course, integrate the GraphDB Workbench with the database as a service version of GraphDB. So we are concluding summary of what we discussed today. Basically, we provide RDF database as a service running on the S4 platform. Graph databases up to 1 million triples are free, instantly available, easy to use, available via standard RESTful APIs. OpenRDF, the most popular API for managing RDF graph data. There is zero administration involved. The platform takes care of all the operations, maintenance, and upgrades, and we have put effort into making resilient and highly available design and platform. So, as I said, if you don't already have an S4 account, you can go to the S4 website, register an account, and get your RDF database running in the cloud right away. And yeah, we provide lots of documentation, demo, support, live chat. You can easily get access to the S4 developers and send us questions or requests. And yeah, thank you for your time.
So, Marin, we do have time, I think, for a couple of questions that have come in. So the first of which has to do with text mining pipelines, custom text mining pipelines. So can custom text mining pipelines be implemented to enrich data and create RDF triples?
Yes. So purification, basically the pipelines that we are running right now on the S4 platform, they are predefined, they are standards for the news analytics domain, social media analytics, life science analytics. But for some particular customers and use cases, of course, we have already been deploying custom private pipelines for a while.
Okay, good. And another one referring to the roadmap, I believe. What is the time frame for introduction of the larger databases?
So that's a great question, actually. We plan to do this as soon as possible. Basically, actually, there is no technological problem to make available the larger databases. We just want to make sure that all these minor glitches which are still hanging are fully fixed before basically we encourage customers to use even larger amounts of data. So we just want to make absolutely sure that everything is fixed, running perfectly, 100% available, and yes, this is why we're still delaying the bigger database options, but we plan to do this within the next few weeks.
Okay, terrific. So I think that should be all the time we have for questions. We do want to keep this under an hour. We didn't get to some, and we promised to follow up through email or phone calls to actually address those questions for you. So we want to thank you for attending today's webinar. Thank you, Marin, for a great presentation. We'll be sending a link to the recording of this event in the next few days, and we'll provide follow-up on the S4 blog. And I've posted that to the chat room if you need that URL. It's a great resource to learn more about our offerings in terms of our graph database in the cloud. So we hope you found today's webinar very useful and informative, and we thank you very much for your time today.